Hi, we're going to talk about magnets. So magnet in Chinese is 磁石. So magnet has two poles, right? So one is north pole, and then one is south pole, right? So if you take a magnet bar, like a bar magnet, then one side will be north and one side will be south. Okay, so you call this one north pole. And you call this one south pole. Okay. And scientists has observed that whenever you cut magnet bars, then this one will become north, south, and then this one will become north and south. So you cut it here, then it doesn't just become a north pole. It automatically will have a south pole there, and this side too would have a north pole there. So it becomes like this once you cut it, right? So you cut it into two pieces, right? Two pieces in the middle. And it becomes like this. So it's always together, right? So never there's no isolated pole, right? It does not exist, right? It always come in pair, north and south, north and south. Okay, so if you cut it again, same thing, you would have, you will have north, south. So you cut this one here, and then you have north, south. You cut this right there. Then you have north, south, and you have north, south. Okay, so automatically become like that. So that's something unique to a magnet. All right. So we'll continue. We're going to talk about magnetic field. And magnetic field line. So just like in electric field, we have electric field and we have electric field line. Okay. So if we take like a bar magnet again, like that, and let's say we have a north here and south here. So scientists has defined this magnetic field line to be like this. Okay, so it comes out from the north side and not entered. Okay, so it will arrive at the south. Okay, it will arrive at the south, and then inside there it would actually continue. So it's a closed loop. You see that? It's not like electric field line. Electric field line started from positive and ends in negative. But this one doesn't end at south pole. It continues inside the magnet. This magnetic field line. So it's a closed loop. Okay. In electric field line, this is not closed loop. This is it go from positive, right? So it go like here, right? So it just go like here, and it stop there. You go like this, and go like that. So this is electric field line. Okay, so this is not closed loop, not closed loop. But this is, all right? So you have more, right? So you can draw more. There's a lot more. And then we'll go in again, right? What's important to realize is it coming out from the north side and then, entering into the south and continue. So inside the bar, it behaves like it's from south to north. But outside of the bar, it goes from north to the south, okay? So that's the magnetic field line. So this is so-called magnetic field line, magnetic field line, okay? But where is magnetic field then? So magnetic field, let me change color here. So let's say if you pick a point right there. So the magnetic field will be going this way. So this is your, I'm gonna call that B, I think, right? So B, that's your magnetic field at that point. Field, right? It's a vector, so the direction point that way, right? Let's give it one more example. So if it's like, I don't know, right here, okay? So then that will be, so it's always tangent to the magnetic field line. So that would be your B at that location, all right? So that's the magnetic field and magnetic field line for a magnet bar or bar magnet, okay? I'm gonna continue on the magnetic field, but now we're gonna talk about magnetic field for Earth. Magnetic field for Earth. Magnetic field and magnetic field line, right, for Earth. Okay, so if we draw like an Earth, like that, oh, almost a circle, right? So let's say we call this one here, right? We call this one here the, what we call that? Like a rotation axis, right? So Earth does a cell rotation, right? So cell rotation axis. Okay, so it goes like this, right? Once a day, right? So there's an omega here, and it's once a day. Right? So it's like a 1, right? 1 rev per day. Right? Okay, now there is, according to the scientists, right? There is a magnet, a big magnet lives inside here. And this is about, this is theta right there. This theta is about 23 degrees. Okay, and so I'm gonna change color. And this is the magnet. It looks like that, a big magnet there, gigantic one, right? Okay, so let's just be clear, right? So this one here, we call that geographic north. So we call this one North Pole, right? When we talk about geography, this is North Pole, right? And this one is South Pole, right? South Pole. So this is geographic south. Okay. But for the magnet, this one here is actually south, right? So this is magnetic south. So again, there's another, you know, like a misleading type of definition when we define north for geography and we define the south for the magnetic. So they are a little bit contradictory, okay? So this is south for magnetic, and so this is south right there, and this is north, right? So if you want to draw the magnetic field line for the Earth, it will be like this. So let's just redraw another one there. Okay, and let's say we call this one here the magnet inside the Earth. So this is north and this is south. Okay, so don't look at this circle now, right? Just looking at this magnet bar, right? So then you know the magnetic field line. It's going to look like this. It's going to come out, go in, right? Come out from here and going to continue inside like that. Okay, and same thing here. All right. So you can draw another one, right? It looks like that. Oops, come in, right? Come on this way. Okay, so now if you go put a compass, right? If you put a compass let's say you put a compass, right? Like that. Okay, so the compass has north and south, right? So the north would be pointing toward the south. So they attract, right? So they're pointing toward that. So just like if you put another compass right there, then this one here will be north, and this one will be south. So that's north, this is south. Okay, and this is north, and so south is pointing, right, toward the north there. Okay, so same thing here, right? This will be north, and this will be south. And if you put it there, right, this will be south. So south and north, right? They attract each other, and this will be north. Okay, so that's the magnet and magnetic field line, and then also the magnetic field for the Earth. That's all we have for today. Hopefully you're learning something about magnet. Okay, all right. Bye-bye.